0.9 recurring is exactly equal to 1, and people aren't happy about it. The first example I used was 1 on 3 equals 0.3 recurring, times it by 3 we get 1 equals 0.9 recurring. The first problem people had is that 0.3 recurring is just an approximation of 1 on 3, but it's not, it's exactly 1 on 3. When using a base 10 system, fractions involving thirds simply don't look nice. Recurring decimal places are exact representations of fractions because they extend infinitely. Then you have people saying 1 on 3 is 0.3 recurring, then a 4. But that doesn't mean anything. The whole point of the recurring part is that it doesn't terminate. By placing a 4 at the end, you assume there are finitely many 3s, which isn't true. Now the last example is what got people annoyed, and instead of 0.9 recurring and 1 are distinct numbers, and there must be infinitely many real numbers between them, but we can't even find 1. The funniest response I found was 0.9 recurring and a half, but there were serious comments supposedly using my logic. But there are infinitely many numbers between 0.1 recurring and 0.2 recurring, for example 0.2, 0.21, 0.211, and so on, so these are distinct numbers. Now on the other hand, I saw a few comments like this, extending the logic to 8.9 recurring equals 9, and so on. And this is true, if you can't find a single real number between them, they're the same. So while it might be frustrating to accept that 0.9 recurring is equal to 1, it's a provable fact that they are completely the same.